Good morning. Today we are going to discuss five variable Karnaugh map. Five variable Karnaugh map. That means, as far as five variables are concerned, using this, that means 16 4 by 4 16, this type of map can have a maximum of four variables. That means here two variables here and two variables here. That okay. When you have five variables, the from the different combinations of or different patterns are varying from 0 0 0 0 to 1 1 1 1, or you have 0 1 2 3 etc. up to 31. That means 32 different possibilities are there for A, B, C, D and E. That means A and A bar, B and B bar, C and C bar, D, D bar and E bar. When you multiply all this, that is 2 raised to 5. That means you have uh, different sets of values for A, B, C, D and E that are designated as 0 to 31. That means now suppose that we have five variables, and here the function is the sum of, that means sum of those products. That means those products are designated as 0 2 3 4 5 etc. That means for 0, that means 0 0 0 0 0, the function of A, B, C, D, E, this returns 1. For 2, means the value is 0 0 0 1 0, this is 2, and for that also it returns 1. For 3 also, that means 0 0 0 1 1, that is also 1. And likewise, you have to encode this using A, B, C, D and E, and for all these variables the values are 1, and then you have to take the sum of the products, and this is the function sigma, this one. And now you have to simplify that using Karnaugh 5 variable Karnaugh map. So in two dimensions you cannot have four variables. For that, what you are going to do is you are going to have two four variable Karnaugh map, two variable Karnaugh maps. Sorry, we have two four variable Karnaugh map, and their variables are A, B, C, D and E. Now for A equal to 0, that means A can take two values. For A equal to 0, we have, that is represented by one Karnaugh map, and when A is equal to 1, you have another Karnaugh map. Now, once A is fixed as 0, now you have four different variables B, C, D and E. Once you have set A is equal to 1, you have another four variables B, C, D and E. That means for various values of this, you are going to have the simplification. So how will you do that? And now the that means sigma of, that means 0 to 31. That means different ABCs are there for 0 to 31. That means you are encoding this like 0 0 0 0 to 1 1 1 1 1. Okay. Now for encoding each one of these, each column is represented by some value and some value. Here now you have 32 columns, and here this is 0 1 2 3 4, this is not 2 3, this is actually 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Now continuing 16 17 18 19 20 21 22 23 24, this is not 24, so 24 is here, 24 25 26 27 28 29 30 31. Okay, now I am going to fill this. Now I am going to fill this. That means 0. 0 is here. 2. 2 is here. 3. 3 is here. 5, 7. 5, 7, 8, 8, 10, 11. 8, 10, 11, 14, 15, 16. 14, 14, 15, 16. 14, 15, 16. 18, 24, 26. 18, 24, 26. 18, 24, 26. 27, 29. 27. 20, where is 27? 27, 29. 29. 27, 29. 30, 31. 30, 31. Okay. See, these are the ones in it. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 values. Okay. Now you have to form groups. That is, here you have to form group means here you are going to have, as I told you earlier, this is something like a cube or something like some folded thing. You can treat like that. That means this is logically adjacent to this is logically adjacent to this, and this is logically adjacent to that. And now we are going to have a group like this. And okay, now see, in this case also something like that exists, and here I am going to name this group as 1, and the same pattern is here. So here also I am going to have the same name first. Okay. Now see, can you have something like, say, here I am going to have a group like this, and here also I am going to have a group like this. Okay, that I am going to name it as 2. Okay, that means same kind of groups if you can form in these two tables, then it's very easy. So now see, nothing like that exists, and here we have a single one remains, that you have to form a group like this. That is, you're going to have the name 3, and what remains here is here 1, 1 and 1. Now we are forming a group like this. Here we are going to have 4, and now we are going to have another name 5. Now we have 5 groups. 1, 2. 1 and 2 are common. 1 and 2 are common for both. First map which has A is equal to 0, and second map which has A is equal to 1, and second is also common. Third one is for the second table only. Fourth one is fourth and fifth are for next table only, or first table only. So how will you form the equation, or how will you generate the equation from this? Actually, the function is 1 plus 2 plus 3 plus 4 plus 5. 1 plus 2 plus 3 plus 4 plus 5. What is 1? I am going to make 1. 1 is here, in both of these cases the same pattern exists. Here A equal to 1, A equal to 0, and here it is A equal to 1. That means that A will go. That means here A and here it is A bar. A plus A bar is equal to 1. That means no more A is there in that product. Okay. Now see which is the pattern here. If you combine these 4 ones. The difference between this and this is 0, 0 and 1, 0. That means 0, 0 and 1, 0 means first B. This is 0, 0 and 0, 1. 0, 0 and 1, 0. What remains is C bar. Here 0, 0 B bar, C bar, and this is B, C bar. That means what remains there is C bar. And if you combine these two, this is D bar, E bar, and this is D, E bar. What remains is E bar. E bar. This pattern is same for both A equal to 0 and A equal to 1. That means A will also go. That means what remains is C bar, E bar. Now take the second one. Second one is also common for both of this. Common for both of this. So what you can do is the A term will go. And now the equation for this you have to find out. That means changing from here to here. Changing from here to here, what remains is changing from here to here, what remains is 1 1 and 1 0. What is 1? 1 is D. D remains. And changing from this to this, that means 1 1 to 1 0. What remains is here it is B. That means BD. Second is BD. That means here this one represents BC and this one represents BC bar. BC or BC bar means B. And changing from here to here, DE to DE bar. That means D also remains. That means BD. Now you have to go for third one. Third one, 3. One thing you should remember, 3 is coming as a part of this only. That means in the first table or first map we don't have 3. That means the replica of this is not here. So you have to, that means for A is equal to 1, this exists. That means A is there. A. For A equal to 1 it exists. And what is 3? That means here there is a change. What remains? This is BCD, BC. That means 1 1 means BC. No change for BC. That means A, BC, and from this column to this column or this cell to this cell, what changes is here it is D bar E and this is DE. That means what remains E. What remains is E. A, B, C, E. And that is third one. What is the fourth one? Fourth one is here. This is the fourth one. That means fourth one is also this is a part of first as a part of the first map only. Second map it doesn't exist. That means A equal to 0. A equal to 0 means A bar, and here varying, that means B and C are varying from B to B and B bar is there, C and C bar, that will go, and what remains is DE. That means A bar, DE. And fifth one, this is, fifth one is, what is that? Here this is part of this first table only. Then you have to keep that A bar, and changing this from this to this, BC. That means B bar C exists. That means A, B bar C, and changing this to this, that means 0 to 1, D will go and E remains. That means this is, so the function is the sum of C bar, E bar, BD, AB, CE, A bar, DE, and A bar, B bar, CE. Okay. And this is the way you can tackle five variable situations using kmaps. Another technique is also which is called kmap that we will discuss later. Suppose that if you have six variable, if you want six variable kernel map, six variable kernel map, what you have to do is now instead of having two tables like this, you are going to have four maps, four maps, four four variable maps. And now how many variables are there? A, B, C, D, E, F. Okay. Now this one stands for AB equal to 0, 0. This is AB is equal to 0, 1. This is AB equal to 1, 1. And this is AB equal to 1, 0. Now you have AB, C, D, E, F. Here also you have C, D, E, F, C, D, E, F, and C, D, E, F. Using this, you can easily do that. That is not included in our syllabus, but it's very easy to do that also. We are continuing with simplification of simplification of sum of products form. That means we are going to find out sigma 1 4. These are the min terms, and if you have up to 4 variables using Carnot map is very easy, but for 5 and 6 variables also we can use Carnot maps. But after that it is very difficult to have Carnot maps, and for that Kuhn and McCluskey developed another method which is called tabulation method or Kuhn-McCluskey method of finding out the simplification of Boolean expressions. And here these are the min terms 1, 4, 6, 7, 8, 9, 10, 11, 15. I am going to simplify that. Here for that, what I am going to do is, here we are going to group these 1, 4, 6, 8, 6, 7, 8, 9, 10, etc. In which these are 1, 4 and 8 are, that means if these are converted to its binary, it is having a single one in it. Single one. That means the code for this is 0, 0, 0, 1. This is 0, 1, 0, 0, and this is 1, 0, 0, 0. Okay. That means in the binary pattern, only a single one is there in it. Here for 6, 9 and 10. 6, 9 and 10, there are two ones in it. That means the binary representation for this is 0, 1, 1, 0. For 9 it is 1, 0, 0, 1, and for 10 it is 1, 0, 1, 0. That means two ones in it. 3 ones are there for 7. 7 is 0, 1, 1, 1, and this is 1, 0, 1, 1. Okay, 3 ones in it. Here for 15 there are 4 ones in it. 4 ones in it. Now after that, what I am going to do is here this is the first group, second group, third group, and fourth group. We have divided this. That means only 4 different possibilities are there. Those are having single ones, 2 ones, 3 ones, and 4 ones. Okay. Now we are going to check whether any entity from this group can be combined with any entity from this group. That means in which the pattern of this and pattern of this is varying only in a single place. Okay, varying only in a single place. To find out for finding out, there is a simple method for that. That means here I am going to combine this 1 with 6, 9 and 10. For that, what you have to do is subtract this from this, and if it is a multiple, if it is positive, you can proceed. That means then you have to find out whether there is a multiple of 2. See, we are going to combine 1 and 6. 6 minus 1 is 5. It is not a multiple of 2. So we are going for the next one. 1 and 9. 9 minus 1 is 8. It is positive and 8 is a multiple of 2. So you can combine 1 and 9, and within brackets you have to write the difference. 1 and 9 is 8. Okay. Now 1 and 10, the difference is 9. There is no possibility for combining. Then go to the next entity, 4 and 6. 4 and 6 is combinable because 6 minus 4 is 2, which is a multiple of 2. 4 and 6 is a multiple of 2. Now 4 and 9. 9 minus 4 is 5. 4 and 10. 10 minus 4 is 6. That means those are not multiples of 2. Now 8 and 6. 8 and 6. When 6 minus 8 it is negative. Those are next one. 8 and 9. 8 and 9 can be combined. Why? 9 minus 8 is 1, which is a multiple of 2. That means 2 raised to 0 is 1. What about 8 and 10? 10 minus 8 is 2, which is also a multiple of 8 and 10. It's a multiple of 2. 8 minus 10 is 2. That means we have combined some entities of this with some entities of the second, and now a group was formed. And now we are going to check whether any entity from this group can be combined with any from this group. For that, what you are going to do is take this and find out the difference. That means 7 minus 6 is 1. That means those two can be combined. 6 and 7 in brackets 1. That means that is the difference. Now, what about 6 and 11? 11 minus 6 is 5, which is not a multiple of 2. Now, 9 and 7. 7 minus 9 is negative. 9 and 11 can be combined. Why? 9 and 11. 11 minus 9 is 2. And next is 10 and 7. 7 minus 10 is negative. 10 and 11. 11 minus 10 is 10 and 11, and the difference is 1. Okay, so it's over. Now you are going to check whether these two can be combined. That means next is 7 and 15. 15 minus 7 is how much? 8. So 7 and 15 can be combined, and 7 and 15, that is 8. 15 minus 7 is 8. Now here we have 4 groups. Here 4 groups. Now we have only 3 groups. Now we are going to check whether an entity from this group can be combined with this, or this can be combined with this. So we are going to check that. Again, there is a simple method for doing that. Here within brackets you have 8. Here an entity from this group, we are going to combine that with an entity from this group. If these two can be combined, this figure will be the same. That means you have to search for entities in the second group which is having 8 in the brackets. We don't have any entity with 8 in the brackets. So move to next one. 4 and 6 bracket 2 in brackets 2. And now you have to find out, or you have to search for entities which is having 2 in brackets. Now this 9 and 11 have 2 in brackets. So one checking one step is over. That means those can be combined. Now another checking is also there. The first term is 9 here. The first term is 4 here. 9 minus 4 you have to. 9 minus 4 how much? 9 minus 4 is 5. It is not a multiple of 2. That means those two cannot be combined. Now we don't have any entities which are having 2 in the brackets. No, moving on to the third one, 8 and 9 within brackets 1. Now here we have 6 and 7 which is having 1 in brackets. Now these are compatible, but when you are checking, doing 6 minus 8, it is negative number, so there is no possibility of combining. We are moving on to the next 8 9 in brackets 1 and 10 and 11 in brackets 1. And now these two are also compatible, but see, 10 minus 8 is how much? 10 minus 8 is 2. That means 2 is a multiple of 2. That means these two can be combined. 8 9, 10 11. You have to write in brackets 10 and 11. Here 8 9 10 11. That means here common is 1. That one you have to write. Now 10 minus 8 you have to write here. 1, 2. Okay. Now there is no more no more entities here having 1, and now we are going to the next one, 8, 10 and within brackets 2. Now if this has to be combined with any entities from this group, the within bracket there should be 2. That means 9, 11 within brackets 2. Now these are compatible for these two are compatible for merging. That means now 8, 10, 9, 11 within brackets 2 common, and now you have to do 9 minus 8 which is 1. That means 1 is a multiple of 2. That means 8, 10, 9, 11 within brackets the common one that I'm going to write, and next 9 minus 8 which is 1, that also have written, and this has been combined with this, and now you are going to check whether this and this are compatible for merging. But here only a single entity is there. Here it is having 8 in brackets. Here we don't have any entity with 8 in the bracket, so that operation is over. That is over. Now see, now this is 8, 9, 10, 11 within brackets 8, 9, 10, 11 within brackets 1 comma 2. That means these two are the same. These two are the same. So I have written that here. Now what you are going to do is you have to find out the prime implicants. That means 8, 9, 10 and 11 you have combined 8, 9, 10 and 11. That means this one represents this. Now the others exist now. So I am going to write 1, 9 in 8 location. This is the first prime implicant. These are the implicants. Now you have to find out the prime implicants. Next one is 4 and 6 within brackets 2. 4, 6 within brackets 2. 4, 6 within brackets 2. Now this is 6 and 7 brackets 1. 7 within brackets 1. And now we have 7 and 15 within brackets 8. 7, 15 within brackets 8. So that's over. Now we have to write this 8 and 10, 11. 8, 9, 10, 11 within brackets 1 comma 2. Okay. Now 1 and 9 here. 1, 9, 4 and 6, 4, 6, 6 and 7, 6, 7, 7 and 15, 7, 15, 8, 9, 10, 11, 8, 9, 10, 11. These are the see. Now you are going to find out the essential prime implicants. These are the prime implicants, and you have to find out the essential prime implicants. So for finding out the essential prime implicants, here this one is coming. That means for each column you have to check whether a single x is there. Here you have a single x. Here you have a single x. That means that prime implicant has to be selected. That means here an x is here in this column we have only a single x, and if this has to come then you have to select this. That means we have selected this also. Okay, this is also having in this column also we have only a single x, so you have to select this and at the same time select this. So this is having 2, this is having 2, this is having only a single x in it. So definitely you have to select this, and once you have selected that, these are all selected. That means once you have selected this, you have selected all this. Once you have selected this, This is also selected. Once you have selected this, definitely this also selected. Okay. Now what you have left is this and this has to come. This and this has to come. So if you select this, that means these are the essential prime implicants and these are non-essential. Non-essential means for this you can either select this or this. For this column you can either select this or this, and for this you have to definitely select this. So that's why this is also a prime implicant. Okay, that is also a prime implicant. That means 6 7, we don't want 6 7. And now we have selected four four essential prime implicants, and with this can generate your Boolean function. You can generate your Boolean function. How to do that? How to do that? Say after generating these prime implicants, you have to draw a table like this. That means here you have A, B, C, and D. That means A stands for 8, 4, 2, and 1. A, B, C. Okay. Now 1 and 9. That means this 1 and 9. The code for 1 is 0001 and the code for 9 is 1001. That means that differs in the this 8 is actually 2 raised to 3. That means here this is at this location. That means 2 raised to 3 is equal to 8. This 3 is coming. This is location number 3. 0, 1, 2, 3. This differs in this location, and that's why you have either way you write 1. That means 0, 0, 0, 1, and 8th location means 2 raised to 3. That means third position, 0th position, first position, second position, third position. You have to cut. That is actually 0, 0, 0, 1, and this 8th position is going to close. Okay. Now 4 and 6. 4 and 6. You have to write 4. 4 is 0, 1, 0, 0, and in the second 2 position is this one, close. 7 and 15. 7 and 15. You have to write 7. 0, 1, 1, 1. And in the 8 location corresponding to 8, you have to cross it. And 8, 9, 10, 11, you have to write 8. 8 is 1, 0, 0, 0, and you have to cross. You have to cross in first and second locations, 1 and 2. Now what remains is this is B bar C bar D. This is B bar C bar D plus what is this? That is A bar B D bar plus what is this? This is BCD plus what is this? A B bar. That means in Kilmakluski method, this is the way you can simplify an expression. You try to do it with more number of variables, 5 variables, 6 variables, etc. Then you will be thorough with that. And with that, I am concluding this session. And next day, I will come up with another topic. Thank you.